Okay, hi everybody. So let's look at problem 9. Write out the first 5 rows of Pascal's triangle. So look this up on Wikipedia and then be able to write out the first 5 rows. And then, part B, calculate this. And so this is just some practice in algebra, but it's really important, as you saw in problem 8. For part C, I have canceled this problem. It is not possible until we learn power series, okay? Which will be what you use in your physics classes. That will be power series, but we're not there yet. Okay, so let's look at problem 10. Define this symbol to be the coefficient of z to the k in the expansion of 1 plus z to the n. So here x is 1 and y is z, or whatever. But yeah, so then what are we supposed to do? Well, prove that this equation holds, okay? And so my solution to this would be to say, hey, first of all, what is even the equation? So I'm not looking, I cannot see it anymore. I should really know or be able to think about what is the equation I'm trying to write down. It's that this symbol is equal to something from the previous row of Pascal's triangle. Or anyway, it's just this, it's like the previous symbols. If we've defined all the symbols up to n minus 1, then we're going to define the nth one. And what will it be? It will be the coefficient of k minus 1 plus the coefficient of k. And so why is this true? So first of all, in my answer, I'll just state what does this mean. So n choose k is the coefficient. I'm going to abbreviate that word, coefficient, then is maybe abbreviated, use maybe 2f's or 1f, it doesn't matter. Coefficient of x to the k in 1 plus x to the n. I prefer x because x is easier to write than a z, which sometimes looks like a 2. Okay. Is it equal to the coefficient of x to the k minus 1 in 1 plus x to the n minus 1 plus, so I just remembered what does this symbol even mean? Now I have plus the coefficient of x to the k in that same thing. So that's the question I'm answering. Is that true? Well, now let's call this, well, the coefficient, this one, well, okay, so really, the insight here, the insight you'll need, well, note that this thing and this thing are related. That is the insight. And so 1 plus x to the n equals 1 plus x times 1 plus x to the n minus 1. Okay, and just to make this concrete, let's do a quick example off to the side of this formula. 1 plus x times 1 plus x to the third. Okay, now 1 plus x to the third is 1 plus 3x plus 3x squared plus x to the third. Okay, that's me practicing this until I'm really good at it from the previous problem. Okay, and what happens when I multiply this by 1 plus x? Well, I either get a 1 times this whole thing, in which case I'll have 1 plus 3x squared plus x to the third. That's easy. Multiplying by 1 is easy. Or I'll get the x. So then I have a plus, right? A plus. Maybe I'll put my plus. Color coding everything. Now I have to multiply the x times this whole thing. And that's also easy. X plus 3x squared plus 3x to the third plus x to the fourth. Okay? Because every one of these just ups the exponent. The exponent increases by 1 when I multiply by x. And now just look at this, like, in words, like, obviously, collecting x to the k's like, let's take x squared. If I want to know what's the coefficient of x squared, well, there's 1 here and 1 here. This one came from x to the 1, and this one came from there. Pause. Do you see what I'm talking about? If I'm interested in the power of x squared, then either it came from the power of x squared and a 1 times that, or it came from the lower power, x to the 1, when it got multiplied by x. Those are the only two places it can come from. And that is exactly going to be, actually this one is the k, and then this one is the k minus 1, right? Because this was the lower power. The blue one got up to power, and so it came from the lower power here. And so, I mean, that's the example. And it really is multiplying this out and seeing that you get these two pieces. So really pause and think about that. The coefficient of x to the k on the right-hand side, that's a often useful abbreviation, right-hand side. You don't need hand, just the right side of the equals of the equation. Here's the equation. Here's the left side. Here's the right side of the equation. That's also a very helpful EQN for equation. The coefficient of x to the k on the right-hand side of the equation either came from 1 times the coefficient of k from this, the 1 doesn't raise the exponent, so it would be the coefficient of k in this thing, or from x times the term in here that had a power 1 less, the k minus 1 less. X times the power of the k minus 1th, the k minus 1th coefficient. So this is the coefficient in front of that power. Here's the coefficient. It's just a number in front of that power. Oops. So you see that this is in words. Therefore, star holds. And what's star? Star is this. I just invented a name for it because I didn't want to rewrite the equation because I knew I had written it up here already. Anyway, the insight here was writing this and then knowing what do these symbols mean. And then maybe also doing an example so you can explicitly see that the coefficient of x squared came from that and that, but this one really came from this lower power after being multiplied by x. This is not easy, but take some time to think about it. Okay. Did my timer go off already? Oh, I have 40 seconds left to keep going. Okay, so give an explicit formula for n choose k. Sorry, this symbol. And this is just a memorization. N factorial over k factorial times n minus k factorial. That's the formula. Just memorize that because it's just going to be so useful in physics that it's just going to be useful. Also in combinatorics, which is a subject in math. Okay, so then just compute this. This happens to be 10. This happens to also be 10. And this, I don't know, so 8 factorial over 5 factorial, 3 factorial. This and this can cancel, leaving 8, 7, 6. All the 5, 4, 3, 2, 1. So then this 3 factorial is really a 3, 2, 1, and the 3, 2 cancels with the 6, so it is 56. Okay. So that's problem 11. That's all.